Dear students, greetings for the day and a very warm welcome for this session. In this session, I'm going to discuss one of the toughest question of GATE 2023. The question appeared in Mechanical Engineering branch, and the idea of discussing the question here is that it will involve multiple points to understand about the permutation and combination. One, if not only such a question can be replicated again by exam, at least some part of this question can be captured here and there, and question based upon them can appear in multitudes of exam here and there. So what we are going to discuss here is slightly on the tedious, cumbersome and the tougher side. So I would like to have your perfect attention over here if you want to understand this question, and the various subparts of this question will still remain to be important for other exams. So I would only request attention from your side. Let's read it, and I will elucidate the question to such an extent that it will appear to be very, very simple, and will divide it into further smaller parts. Let's see. Let's go ahead and let's hold the bull by horn. So how many pairs of set S and T are possible among the subsets of 1, 2, 3, 4, 5, 6 that satisfy the condition S is a subset of T? तो अभी हमें इतना जान के क्या समझ में आया, मैं सबसे पहले इसे बहुत इजी बना देता हूं. सबसे पहले हम इस गिवन सेट को नाम देते हैं P. तो एक हमारे पास सेट है जिसके अंदर ये भी बोल सकते हैं डाइस है, डाइस के आउटकम्स हैं, वेरियस आउटकम्स. सो P इज दिस सेट. नाउ S and T are among the subset of P. So S and T are subsets of set larger set P. S and T are subset of larger set P, and further he says S is a subset of T. S is a subset of T. S is a subset of T. So first of all, what we have understood here, this P was not given here. मैंने उसे नाम दे दिया P का, कोई प्रॉब्लम नहीं है. P is a set. S and T are subset of P. S और T जो है P के सबसेट है, और S is a further subset of T. So how many such ordered pairs can be there? A wonderful one. And I only require your utmost importance here so that I can explain you this wonderful concept and this wonderful question. So before we move on to the question, you should be knowing certain fundamentals. I am using a pre-slide, though I generally avoid it, but in order to cut short the length of the question, I will be using the binomial expansion directly. So x plus a binomially expanded will be equal to nc0, x power n, a power 0, nc1, x ka power will keep on reducing and a ka power will keep on increasing. I hope everybody is aware of this binomial expansion of x plus a raised to the power n. Now, if I'm going to put here x equal to a equal to 1, this particular expression reduces to 2 power n. Put x equal to 1, put a equal to 1, so it will become 2 power n. This is equal to 2 power n, and everything here will become 1. X is 1, a is 1, x is 1, a is 1, so we'll be left with only coefficients. So coefficients will be nc0 plus nc1 plus nc2 and so on up till ncn. So we can say nc0 plus nc1 up till ncn should be equal to 2 power n on putting x equal to 1 and a equal to 1. I hope this makes absolute sense with everybody. Let's build the idea further on, and we know number of subsets of a set having n element is 2 power n. This is phenomenally important and can be directly used in multitudes of exam. मैं आपको क्या बताना चाहता हूं, यहां पे कोई सेट है, सपोज कोई सेट है जिसके पास एक ही एलिमेंट है a. सो इसके सबसेट क्या होंगे, a and phi. इसका सबसेट होगा, there will be two subsets. And one more thing you can add here, phi is a subset of each and every set. Phi is a subset of every set. ये भी आप चाहे तो बेसिक में ऐड कर सकते हैं. सो एक सेट है जिसका एक ही एलिमेंट है, there is only one element inside it. Its subset will be a and phi. There will be two subset of it. Now, if I take a set having two elements a and b, its subsets that are going to be possible is a and a set containing b, a set containing ab, and as well as a phi. So this will have 2 power 2 subsets. Try to get hold of the concept. And if we have a set A, B, C, how many subsets? This is a set containing 3 elements. How many subsets? A is a set containing C, and then we have a set containing AB, then we have 2 taken at a time, BC, then we have AC, then we have ABC, and then we have a 5. Wow. So 1, 2, 3, 4, 5, 6, and 7 and 8, that is equal to 2 cube, right? Which is nothing but it is coming from here. We are not selecting any element, NC0, NC1, NC2 up till NCn, that will be 2 power n. So a set containing 1 element will have 2 subsets. Phi is a subset of each and every set. A set containing 2 element will have 4 subsets, and a set containing 3 element will have 8 subsets. Also, if we take a null set, if we take a null set, its subset will be null set. So 2 power 0. If a set does not contain any element, its subset will be the same set, phi set. So there is only one. There is only one subset. Phi ka subset will be equal to phi. So we have generalized the result. If a set contain no elements, it will have only one subset, 2 power 0 subset. One element, 2 power 1 subset. 2 elements are there in a set, its subset that are possible is 2 square. And if there are 3 elements, its subsets will be 2 cube. I hope I am very well able to explain this axiom which I am directly using out here. Number of subsets of a set containing an element is 2 power n, and we have assumed phi is a subset of each and every set. All these things are absolutely clear with everybody. I'm not trying it for 4. If a set will contain elements A, B, C, D, so surely we can selecting no at a time, 1 at a time, 2 at a time. So 2 power 4 will come out to be 16 subsets will be there. Now guys, I will need your utmost attention here. Let's move back to the question. Now here the question says, how many pairs of set S and T are subsets of this set P, and S is a subset of T? So we have to move forward in this order. I will reduce the font of the question, and now I will start from here. P I take, P is, we have here 1, 2, 3, 4, 5, 6. Now P is this set containing 6 elements. If I take a set T contain only 1 element. So its number of subset S should be a subset of T. So S can have values, S can have 2 values, 1 and 5. So it will be 2 power 1. If I similarly contain here this 1, I am going to get T is a set containing only 1 element out from here. Its subset S. S is a subset. T and S both are subset of P, and S is further a subset of T. If T contain 1 element, its subset will be equal to 2. But make sure T had contain numeral 1. T can contain similarly numeral 2. T can contain numeral 3. T can contain numeral 4, and T can contain. So this set T containing only 1 element could have been done in how many ways? 6C1. 6C1. And for each of these, the number of subset which S is going to have will be 2 power 1. Similarly, let us move here. Similarly, if T contains only element 2, it is again going to have 2 power 1 sets. T contain element 3, again 2 power 1 subset. So this element, we are selecting only 1 element from P, which is T. That can be done in 6C1 ways, and for each of them correspondingly there will be 2 power 1 subset. I hope इतना अच्छे से आपको क्लियर हो गया होगा. दूसरी बात मैं यहाँ पे आपको बताता हूँ. Now suppose T contains 2 element. T contains 2 element 1 and 2. T contains 2 elements. Its number of S is a subset of T. It can contain 1, it can contain 2, it can contain 1 and 2, it can contain phi, it will contain 2 power 2 subset. But T could have taken values 1 and 2, 2 and 3, 3 and 4, 1 and 6, 5 and 6. That means T can contain 2 elements at a time from P. If T is a subset of P, we are considering all T which contain 2 elements. These 2 elements can be 1, 2, 1, 3, 1, 4, 4, 5, and so I am selecting 2 elements from P. They will make T. Then the number of subset that S are possible will be for each one of them will be 2 square. And same thing if I contain T as a set which is a subset of P, it will contain 3 element. Number of subset S is a subset of T are possible. We have 1, we have 2. In a very similar way as I have done in the beginning, we have here 1 and 2, we have here 2 and 3, and we have here 1 and 3, and finally we have here 1, 2, 3, and finally we have here 5, 1, 2, 3, 4, 5, 6, 7, 8. I need not to explain it because I have already explained if T contain 1 element, subset will be 2 power 1. T contain 2 elements, subset will be T contain 3 element, subset will be 8. But I am selecting how many elements? T में मैंने कितने element यहाँ से select करे? 3 element from set P. 3 element can be selected in 63 ways. 3 element can be selected in 63 ways. And for each of them, the S correspondingly can be done in 8 ways. S correspondingly done. I hope I need not to explain further on. If I take here T, any 4 elements, any 4. So first of all, I have to select which 4 elements, and for them, S can have 2 power 4 values, and so on. Let me bring it here and let me take this complete thing over here so that I will be very well able to explain the things. Now, if I take any 4 elements, any 4 element from P can be selected in 64 ways, and for each of them, S can take how many subsets? This way. And same thing if I take any 5 element, any 5. First of all, we have to select which 5 element. Which 5? Which 5 element? Any 5 element that can be selected from these 6 element in 65. 65 ways, and for each of these cases, S can have correspondingly 2 power 5 values. So 2 power 5 values, and if I select all elements from set P, if now T will remain to be a subset of P. S for further subsets that are possible in S will be 2 power 6. And for selecting all 6 elements, there is only one way. 66 is 1. But don't forget, one of the option was there. There were 2 options which were misguiding options. Don't forget one thing. If I will not select any element from set T, I have not selected any element from set T, then S will have only one possibility. Phi is a subset of phi. Now, first of all, is T and S both subset of P? Yes, sir. Is S is a subset of T? Yes, sir. Because T contain no element, S will contain no element. S and T, are they both subset of P? Yes, sir. And S, is it a subset of T? Yes, sir. So this thing, never miss out this thing. I am selecting none of the element from there, and still I'm going to get 2 power 0. That means only one subset. So finally we have cracked it. We have arrived at the solution. I will not only hold it here. I'm going to explain you a couple of more important things here. Now if I want to solve this value, so what will happen? This value, just now we need a numerical addition of these value. 60 is eventually equal to, this is 1, and we have here 1 into 1 plus we have a 66, 6 into 2, that is equal to 12, and we have a 62, 6 into 5 by 2, that is 15 into 2 square is 460, and 63, 6 into 5 into 4 divided by factorial 3, that is equal to 20 into 2 cube, that is equal to 8, right? We have a 64 is equal to 62. 64 is equal to 62, that is equal to 15 into 16, and we have a 65, that is again 6 into 32, and we have a 66, that is equal to 1 into 64. Now it's a Herculean task to add it, but it's a gate question. There is not much of a problem here. 1, 12, 60, 160 we have, 240, am I right? Yes. And here we have here 192, 180 and 12, yes, 192, and we have here 64. If you'll ask me to add them, what I should be doing in order to add them, I hope you're getting a complete hang on of the things. This is equal to 301, 400, 400, and here we have here 73, 473, and here I have here 256, 400 and merely 256. If I add them, 729. So what I'm going to get here is 729. Wow. 73, sum of these three values. I hope it can be easily done. Calculator is also allowed in GATE, and here we have here how much? 256. So if I add them, so this value is coming out to be 729. Let me further once again give you a complete explanation of it. What the question was saying, P is a set which contains these 6 elements. Now he is saying S and T have to be a subset of P. S and T have to be a subset of P. Further, S is a subset. S is a subset of P. S is a subset of P. Font size has become quite small. Kindly excuse me for that, because I want to capture the entire stuff on the board. So kindly excuse me for that, else everything will remain to be perfectly okay here. Now, what we have, P contain 6 element. If we do not contain any element from P, that can be done in 6C0 ways, and that means it does not contain any element. So T is a subset of P. Further, S should be a subset of T. So S will also contain no element. Phi is a subset of each and every set. One such thing I've got 6C0. And for this value, the corresponding subset is phi, only one such value. If T contain only one value, which value? It need not necessarily needs to be one. ऐसा नहीं है कि वन ही लेगा. T कोई भी वैल्यू यहां से ले सकता है. कितने तरीके से छांटा जा सकता है उसे? 6C1. कोई भी एक वैल्यू छांट ली. 1 सेलेक्ट कर सकते थे, 2 कर सकते थे, 3 कर सकते थे, 4, 5, 6. Corresponding to each value, S will have 2 values. S will result in 2 subsets. So for each of these values, S will result. And if we select 2 elements, which 2 element? Any 2 element, 1 and 2, 1 and 3, 4 and 5, or any 2 element, that could have been done in 62 ways. And for each of them, the S will corresponds to 2 square subsets. S is a subset of T. T and S both are subset of P, and S is a subset of T. Wow. If we select 3 elements out from here, so any 3, that can be done in 6C3 ways, and for each of them, S 1, 2, 3, 3, 4, 5, for each of them, S will be corresponding to 2 power 3 subsets. And similarly, we select 4 elements, 2 power 4 subsets, any 5 element out from there, 2 power 5 subsets, and any 6 element out from there, 2 power 6 subsets. If we add all of them, this value is going to result in 729. Wow. One more thing, how I can explain you. Let's see, this was the question in front of us. One more thing, just hold on. Give me 1 more minute and I'm going to do a terrific value addition here. Phenomenal value addition. Just hold on for a while. How many pairs of set S and T are possible among the subsets of 1, 2, 3, 4, 5, 6 that satisfy the condition S is a subset of T? P is the given set, S and T are subset of P, and S is further a subset of T. We have followed every condition. Answer is 729. But I want to explain you one more very important thing, that this value eventually, whatever value I have got at the end, जो वैल्यू मुझे यहाँ पे अंत में मिली है, ये हमारी आ रही है 729. जनरलाइज करके देख लेते हैं इस फॉर्मूले को, हाउ ब्यूटीफुल इट विल अपीयर इफ आई सी a really simple thing. In this binomial expansion, you hold on for a minute and you let me put here x equal to 1, a equal to 2 and n equal to 6 inside this binomial expansion. X I'm putting 1, a I'm putting 2, so this will become, and n I'm putting as 6, this will become 3 power 6. So that is equal to 729. We'll be arriving to it later on, but first of all, let me explain you. This will become 6C0 1 power. 1 की power लिखने का कोई फायदा तो है नहीं, into 2 power 0. We have 6C1, 6C1, 1 का power 5, 2 का power 1. कोई जरूरत नहीं. Now I will not be writing 6C2, 2 का power 2. I am not writing 1 का power 4, right? 6C3, 2 cube, 6C4, 2 power 4, 6C5, 6C5, 2 power 5, 6C6 and 2 power 6. Please see here. This is nothing but 3 power 6, which is equal to 729. Remove 1. 1 power anything is 1. 1 power anything is 1. And so here we have 6C0 into 2 power 0, 6C1 into 2 power 1, 6C0 into 2 power 0 into 2 power 1, 6C2 into this, 6C3 into this, 6C4 into 2 power 4, 6C5 2 power 5, 6C6. So this is nothing. This complete value is what we have got here previously. You see, 6C0 2 power 0, 6C1 2 power 1, 6C2 2 square, 6C3 2 cube, 6C4 2 4, and on adding it, it is coming out to be 729, which eventually we could have looked from there that this value was eventually nothing but binomial expansion of 1 plus 2 raised to the power 6. So generalized answer for it is 3 power 6. Wow, that is one more shortcut which we have arrived at. तो ये आपको आ गया होगा समझ में. this the upper line is exactly same as this line. This upper line is exactly same as this line. So for any such question, I hope इस क्वेश्चन से आपको बहुत सारी चीजें सीखने के लिए मिली होंगी. दो I hope the length of the question could have been shortened. I have tried my best to explain multitude of things here, but still, if you want to have a shortcut for it, so if this set P contains 6 elements, answer in such a case will be 3 power 6. And similarly, if this set P will have n element, if P could have element 1, 2, 3, so on up till n, and further given condition P has element up till n, S and T are subset of P, S is a subset of T. How many ordered pair are possible? Now the answer have to be 3 power n. Now the answer have to be 3 power n, because answer is coming from this rule on putting A as X as 1, A is 2 and power n. So the general answer will be 3 power n. Here P के अंदर एलिमेंट थे 6, तो 3 power 6, 729 was the answer. So we have developed a generalized formula for it as well. If it will contain, it will go up NCN 2 power n, which will be equal to this complete expression will be 3 power n. So the generalized formula for it will be 3 power n if set P contain n elements. I hope you have understood lot of concept through it. I will display it once more completely on the board so that you guys can get a hang on of the things. So we'll come up with many such interesting videos in the future as well. May you always rise higher and shine brighter.